Hi, in this election I'm going to demonstrate how to tabulate the results of an election using sequential Monroe proportional score voting or reweighted range voting. I'm still working on naming for this system. It's kind of a hybrid of two separate ideas. If you check out the web for reweighted range voting, you'll see a fair amount of information about that. These are based on a score voting ballot, so what's happening here is the voters are rating the candidates on a scale of 0 to 5. So not ranking 1, 2, 3, but rating 0 to 5, just like a Yelp review or Amazon.com review. And so each row here represents a voter, and each column represents a candidate. So this first voter gives Pete a 5, Joe a 5, Corey 4, Liz 1, Barry 0. I just randomly picked these names. You can tell they're the names of some Democratic politicians. And other than that, there's nothing else realistic here about this. I've just assigned random scores here, so there's no sort of realistic correlation between the scores with these candidates. They're just funny names. I'm going to go into the math a little here further on in the video, but I just want to start out by saying that this system is going to give you proportional representation, but it's going to do so with much simpler math than is used by, say, single transferable vote, which is the proportional voting method used in Australia and Ireland and some other places. So the way it's going to work is we're going to look at who got the most total points here at the bottom. But you may notice that these are much smaller numbers than the totals of all these numbers in the columns. So what we're doing here is we're basically defining a quota of voters as the total number of voters divided by the total number of winners. So we're going to elect 3 winners here to make this proportional. So we're imagining we have a district which is at large and it elects multiple winners at the same time. And since there are 18 voters divided by 3 winners means that within each block you have 6 voters. We're just attempting to find the candidates who would most satisfy a particular group of voters, particular faction of voters with equal block sizes. So we look here and we see that Pete has 7 5s. 7 different voters have given him 5. So if we take the 6 highest scores of that whole list, they're 5s. 6 times 5 is 30. So he got the most you could possibly get from a quota of voters, which is 30. So he's the first winner. And look what happens here. Instantly you have this weight column over here, and it changes. So for instance, this first voter gave Pete a 5, was the maximum score. Pete won. Now this voter has half of the starting weight. Whereas this voter on the third row here gave Pete a 0, and so still has 100% of the starting voting power. 1 times anything is still just that same number. This represents 100%. And you see another voter here gave Pete the minimum score that is actually more than 0, which is 1, and so has 5/6 of her starting power, which is almost the total amount that she started with, but just a little bit less because she gave Pete just a little bit of support, right? So you're just weighting these down in proportion to how many points were given to each candidate. You're sort of spending your power as you help to elect candidates of your preference, right? So now we're going to go to the second highest score, or the next highest, which would be obviously Barry with 22.45. But notice something interesting here. When we started, Barry was not the number 2 candidate, right? It was Pete with 30 and then Joe with 29 and Barry with 27. The reason that this switch happens is that after Pete is elected, a lot of these voters, when they get down-weighted, a lot of them also had an affinity for Joe. So Joe loses a lot of support, and there was less correlation between Pete and Barry and some of these other candidates, so they are less penalized. Those voters are sort of down-weighted less who supported Barry, and therefore Barry actually overtakes Joe. And this is a result of it being proportional. The camp that likes Pete also likes Joe pretty well. They've already elected Pete, so now another camp is going to have a say in the outcome. So Barry is our second winner. And then the next winner, the third winner, is going to be Corey with 15.64. So let's go put the 3 here. And there we have it. If we were to keep going, we could. No matter how many winners there are, it doesn't change the spreadsheet formulas, but we're just going to take the first 3. And there you have it. We have our winners. Now let's look at how easy this is to perform. If you look at the weight formula here, we're just saying we're summing. If there's any marking in this row here where we give them rankings, then it's going to go ahead and include that as part of the weighting, that candidate score. And then we do the division here. So this is a pretty simple formula, and it's the same formula all the way down this column. And then we have this formula for the column totals. We're just doing sort n, which is a function which lets us take the top n values, or minimum n, in a list, and then we can feed that into the sum function. So we're basically saying just go down this list and pick the top 6 highest values, and then just sum them together. And it's really, really simple. And that's it. Now, if you take that simple math that you just saw in those formulas, and then you go look up the definition on, say, Wikipedia of how single transferable vote works, I think you will notice just a dramatically simplified system compared to STV. And it also uses a simplified ballot because the length of the ballot may change. It may get very long with a lot of candidates running, but the width will only ever be that 0 to 5 scale for your scores. It will never get any wider than that. Whereas if you're looking at a single transferable vote election with, say, 20 candidates, you need to have 20 columns if you're using a standard ballot layout so that you can have a unique rank for each candidate. And this is because it's totally fine to give multiple candidates the same score. That's part of the benefit of using scores instead of ranking. So scoring or rating over ranking. So think of Yelp or Amazon.com reviews where you're using points instead of rank orders. And that's that. If you want to know any more, you can read about the derivation by Googling reweighted range voting. That's where we got the weighting formula from. And I appreciate your watching. Thanks.